Hello everyone, welcome to today's class. This is Teacher Simon taking you through Cambridge International AS and A-Level Pure Mathematics 3, Paper 3 for May-June 2024, and this is part 1 for questions 1 to 6. Number 1 is coming from exponential functions or initial equations. We are supposed to solve the equation as given here, and then we give the answer to 3 decimal places. There are 2 methods I'm going to use while solving this, okay? So let me first divide this one into 2. So the first one, I'm going to use indices. This one is the same as 8 out of 8. This is 8 power 3, then 8 power 6 here. Remember, in indices, when we divide the same bases, then we subtract the powers, okay? So this is where this one is coming from. And then here we shall have 4, then over 5 power 2x, okay? Then I have to put those parts that have gotten x onto one side, okay, onto one side. So I can cross multiply, and I have 5 power 2 of x, then we divide by 8 power 6 of x. This one is the same as saying 4 over 8 cubed, okay, like that. Or I can write this 8 power 6x, then divide by 5 of 2x. I can bring this one here, then take the 4 here, okay. It's also the same. Now, after that, in indices, we have a rule that a over b, if all of them, the power of x, this one is the same as a power x over b power x. So I can write this 5 squared over 8 power 6, all of them are to the power of x, okay? Remember also a power b power c is the same as a power b times c, okay? So this x here multiplies with these 2 to give you this 2x, okay? Just like this x and this 6x. I mean 6, when you multiply them, then it give you that 6x. So meaning here we can have 4 over the 8 cubed. So I will have that 25, then out of the 8 power 6, okay? Then power x, which is equal to 4 over 8, then power 3. Then I can introduce logarithms on both sides. So natural log of 25 over 8 power 6 of x is equal to the natural log of 4 over 8 power 3. Then using the rules of logarithms, this one can come down here. Okay, so we shall have x, then natural log of 25 over 8 power 6, which is equal to the natural log of 4 over 8 power 3. Automatically, our x is going to be equal to the natural log of 4 out of 8 power 3. Then we divide by the natural log of 25 out of 8 power 6. So when we put this one in the calculator, what do we get to 3 decimal places? We have natural log of 4 divided by 8 cubed, 8 then cubed, and then we close the brackets. Then down here we shall have natural log of 25, then divide by 8 power 6, 8 then power 6. So we close the brackets here. Everything gives us 0.524. So 0.524. This is to 3 decimal places, okay? That is one way to do this. The other way is going to be, I will introduce logarithms right away, okay? So introduce natural log of 8, then power 3 minus 6x. Then this one is going to be equal to the natural log of 4, then times 5 power negative 2 x, like that. And then we apply the rules of logarithms. So this one will come down here. We shall have 3 minus 6x. You put this in bracket because we are having 2 terms in there. Then natural log of 8. Then this one is equal to the natural log of 4. Then plus, because this is multiplication of the powers, so this one comes from the addition of the 2 logarithms. Okay, just like that. Then we can open the brackets. So 3 times natural log of 8, and then minus 6 of x times the natural log of 8. Then this one will be equal to natural log of 4, then minus 2x natural log of 5. Okay, remember this one goes down. All right, then we can put x onto one side. So we shall have natural log 3 natural log of 8 minus natural log of 4. That is when I bring this one this side, and then I can take this one this other side. Okay, so when I take it there, it becomes a positive. So 6x, then natural log of 8, then minus 2x natural log of what? 5. Then this one can be, I can write it just like the way we have this one here, whichever way. So I can write natural log of 8 power 3, then minus the natural log of 4. This one here, x is common, so I'll have 6 natural log of 8 minus 2 natural log of 5. See that? So we shall have natural log of 8 cubed here out of the 4. Then this one will be equal to x into, this will be natural log of 8 power 6. First take this one up, and then apply the rules of logarithms. This one is going to be apply the rules of logs. So we shall have this one as 25, okay, down here. So we have something like that. Then our x is therefore going to be the natural log of this 8 power 3 over 4. Then divide by the natural log of 8 power 6 over the 25. Okay, so when we press in the calculator, what do we get? Okay, and by the way, if you check what I'm having here, 4 is up here, 8 is down, and here it is the reciprocal. So I can make this the same. If I put a negative on this, if I multiply by a negative and a negative here, and then I take this one up, then this one will somersault. The same thing with this one, they will somersault, and then they give you the same thing here. We have natural log of 8 cubed, then out of 4, then down we have natural log of 8 power 6, then this one is out of 25. It gives us the same answer, 0.524 to 3 decimal places. So meaning you can introduce logarithms at first, okay, right away, just like here, or you can use indices, and then you put the terms that have got an x onto one side. Then after simplifying there, now you can introduce the logarithms. So either way, you get the answer. Number 2, find the exact coordinates of the stationary point of the curve y is equal to e to the power of 2x, then sine of 2x, for x ranging from 0 to pi over 2. You know that for stationary points, dy dx is equal to 0. And here we are going to use the product rule because this is a multiplication of two functions. So we are going to have this e power 2x made constant, and then we differentiate sine 2 of x. Then from there, we can keep this sine 2x, and then we differentiate the e power 2 of x. Then from there, we can equate this to 0, okay? Because for stationary points, like I said, dy dx is equal to 0. Now, when you differentiate a sine, you get a cosine. So we shall have cosine of 2x, but we shall multiply by a 2, okay? Because when you differentiate this angle, we are using now the chain rule in there. So you enter inside the angle, you differentiate it, you get a 2, then you multiply it all through. And then there is this e power 2x here. And then also, when you differentiate with respect to x e power a function, you just get the power of that exponential function, you differentiate it, then after you multiply all through by that function, that exponential function, okay? So what we are going to do here is the same. We are going to have plus, then sine of 2 of x times, when we differentiate this one, we get a 2. So we shall have 2, then e power 2x, which is equal to 0. Now, 2 e power 2x is actually common. So I can factorize it here, and then I say this is cos 2x, then plus sine 2 of x here. Okay, then this one will be equal to 0. Then that means any of these two factors can be equal to 0. So this one is equal to 0, but this is undefined because there is nothing that you're going to power this e with, and then you get a 0. Okay, now I can also have this cosine of 2x plus sine of 2x, which is equal to 0. I can divide this all through by cosine of 2x, okay? Cos of 2x. Now, when I do that, even this side, of course. So here we shall have a 1, then here we shall have tan 2x, then which is equal to 0. So meaning tan of 2x is going to be equal to negative 1, and then 2x is going to be the arctan of negative 1, okay? So tan is negative in the second quadrant and fourth quadrant. So I always draw my circle here like this. If you have been following me, you must have seen me always drawing this. So this is 0 to, this is pi over 2, then this is pi, then this is 270, which is 3 pi over 2, and then this one here is 2 pi when we come back. Now, when I project this angle here, let's say it is theta, then even here theta, that means this is the same also, theta here. So to move from here up to here, in the second quadrant, we must say pi minus that theta. And then here it is pi plus theta, then here it is 2 pi minus theta. So you are moving like this up to here, okay? That is that. Now, tan, you can ignore the negative, okay? You will get 45, which is pi over 4. So you get that angle 45. This is 2x is going to be equal to. Now, you go to the quadrants where tan is negative. Tan is negative. This is A, S, T, C. Tan is negative here and here, okay? So we are going to pick an angle from here. So it is going to be that pi divided by this, minus this pi over 4 when you ignore the negative, okay? So we are going to have pi minus pi over 4. Again, where cosine is, where tan is negative is here. So 2 pi minus that pi over 4. And then our x is going to be a half of the answers we get here. So this will be 3 pi over 4. And then this will be 8 minus 1. That will be 7 pi over 4. Okay? So meaning that x can be equivalent to 3 pi when you open the brackets, 3 pi over 8, and then 7 pi over 8. Okay? Now, our x here, they said that it has to range from 0 to pi over 2. Okay? So let's check what we have here. Pi over 2, that is 90. So if I have 3 pi over 8, this one is giving us 1.178. Now, when we have pi over 4, okay, pi over 2, that's the 90 degrees. Is the other one we have gotten, the 3 pi over 8, is it less or greater than that? That's what I'm trying to find out. This is 1.57. The other one is 1.178, so it is smaller. How about this 7 pi over 8? 7 pi over 8. It is 2.74. Yet, pi over 2 is 1.57. So that means this one is bigger. Okay? This one is bigger. So we shall leave it out. And then we shall take our x, which is equal to 3 pi over 8. So for x, which is equal to 3 pi over 8, what will be y? So y here was given as e power 2x sine 2x. E power 2x then sine 2x. Like that. They told us to give the exact coordinates, so we have to leave it exact. Okay? Now, if it is exact, then let us just simplify this one here. 2 goes here 4 times, right? So we shall have 3 pi e power 3 pi over 4. And then sine of this one here is 3 pi over 4. So sine of 135 is the same as sine of 45. Okay, so let's check it out. The calculator, let me put it in radians. Then we have sine of 2 pi. That may be 6 pi. Okay, let us write 6 pi out of 8. It is root 2 over 2. So here we shall have times root 2 over 2. So meaning the coordinates of the stationary point are going to be 3 pi over 8 as the x coordinate. Then the y coordinate is root 2 over 2. Then e power 3 pi over 4. Like that, exact. We don't need decimals. Number 3, the square roots of 24 minus 7i can be expressed in the Cartesian form x plus iy, where x and y are real and exact. So if they say and exact, that means we can get the square roots there, we leave them there in the third format. So by first forming a quadratic equation in x or y, find the square roots of this in the exact Cartesian form. Now, if we are having a complex number, the square root of that complex number is also a complex number. So if I have the square root of this 24 minus 7i, this one will give us that complex number, which is x plus I, y. Okay, now we can square both sides. When we square both sides, this one will remain as 24 minus 7i. Then here we have x plus iy squared. Okay, so we can expand and then we equate the real and then the imaginary parts. So this will be x squared, then plus 2xyi, because you get this 2 times this times that. Okay, then after we square this one here, we shall get I squared, y squared. But you know that I squared is equal to negative 1. So meaning you have 24 here minus 7i, which is equal to x squared minus y squared. This one becomes a minus y squared. Then plus 2xyi. Now we equate, okay, equating real and imaginary parts. So complex numbers are said to be equal if the real parts are equal and the imaginary parts are equal. So the real part here is 24. So I will say 24 is equal to, the real part here is the one that doesn't have the I. So we have x squared minus y squared. And then the imaginary part here is negative 7. So we shall have negative 7, which is equal to, this way we have 2xy. So 2x and y. So I can express either x in terms of y or y in terms of x. So from here, y can be equal to negative 7 over 2 of x. So meaning when I substitute in here, I will have x squared minus y is negative 7 over 2x. Then we square it. Then we equate to 24. So simplifying this, it will be x squared, then minus, this will be 49 over 4x squared. Okay, then which is equal to 24. Now I can multiply everywhere by 4x squared to eliminate the denominator here. So here we shall get 4, then x power 4. And then when you get this times this, of course it disappears. So we shall get negative 49. And then 24 times 4, that gives us 96. So we shall have 96 of x squared. So when we bring this one this side, we shall get a quadratic equation, 4x power 4. Quadratic because the degree here is 4, okay? Minus 96x squared, then minus 49, which is equal to 0. So this one is a quadratic. It's a quadratic equation, but it is a quadratic equation in x squared. Okay, so we can put this in the calculator to simplify. Okay, go to mod, then equation is 5, the quadratic is 3, our a is going to be the 4, our b is going to be the negative 96, and then our c is the negative 49. Then this one will give us 49 over 2, and then negative a half. 49 over 2, you can first skip space and you say x squared is equal to 49 over 2, And then the other one, x squared is, remember it is a quadratic in x squared, that's why I'm writing x squared, okay? This one is equal to negative a half, okay? Then when you write this one here, you have not attempted to solve the quadratic equation, because there is always a mark they give for attempting to solve the quadratic equation. So this is how you can show the examiner that you actually did the what? You attempted to solve that quadratic equation. So cross multiply. We need to get a factor from which this root comes, okay? So when you cross multiply, you will get 2x squared. Then bring the 49, it will be minus the 49. Then also here, cross multiply. This one will give us 2x squared. Then bring the negative one, it will be a plus. So there you have cheated the examiner. You see that? Now, of course, this one is undefined. Remember, they said the values of x and y must be real and exact. But when you get the square root of this one, it is going to be a complex root. You see that? You are going to get an I, so leave that alone. It is undefined. It is not in the real system. So meaning our x here is going to be this plus or minus square root of 49 over 2. Okay? And this one can give you plus or minus 7 root of 2 over 2. Because you get 7 over root 2. And if I can say times root 2, then times root 2, this one here gives you 2. So that's why you get this one down here. Okay? All right. Then after that, for each of these two values, we get the values of y. So for x which is equal to 7 root 2 over 2, what will be y? So y is going to be equal to, remember up here, y is this one here, negative 7 over 2 of x. So it is negative 7 over 2. Our x is now 7 root of 2 over 2. Do you see that this one is going to cancel with this? Then this 7 will cancel with that. Then we remain with the negative 1 over root 2, which is actually the same as negative root 2 over 2. Okay? So meaning one of the roots, which I can call maybe z1, is going to be 7 root of 2 over 2. Then minus root 2 over 2 of I. Okay, remember it is x plus yi. You see that? Okay, then how about the next one here? For x, which is equal to negative 7 root of 2 over 2. Remember, when you take the square root, you have plus or minus. Okay, so y is going to be equal to negative 7 over 2, then times negative 7 root of 2 over 2. Of course, the negative cancels just like the other one. We are going to have now a positive 1 over root 2, which is the same as root 2 over 2. Okay, so this is one answer here. And then the other answer, the other square root, is going to be negative 7 root of 2 over 2. And then minus, it is a plus, root of 2 over 2i. Now, these two square roots are not complex conjugates of each other. Usually people do this. When they get this one here, then they just conclude that the other one is going to be, if here I have a minus for this imaginary, then I just do a plus for this. But do you realize that what we are having here, this one is positive, but this one is negative. So for the complex conjugates, the real part is the same. The imaginary is the one that is different, because these two are actually reflections of each other in the real axis. Okay, so substitute each of them that you have gotten. Usually those who do that, they always forget this plus or minus when they take the square root here. So that is what we are supposed to get there. Question 4. The variables x and y satisfy the equation ky is equal to e to the power of cx, where k and c are constants. The graph of natural log of y against x is a straight line passing through the points, these ones here, as shown in the diagram. Find the values of k and c. Give each value correct to two significant figures. Now, before you start such questions, always look at what they have labeled your axes with. This is natural log of x, this is x. So that means that what we are having here in the coordinates, this one is an x, but this is a natural log of y. It is not y, it is a natural log of y. So even this one is x, and then this one is the natural log of y. Now, we introduce logarithms on this equation here. So introducing natural log here of ky, which is equal to natural log of e, then power cx. Of course, this is a multiplication of the two, which is coming from the addition of logarithms. So we shall have natural log of k, then plus the natural log of y. Then this one is equal to, applying the rules of logarithms, again, bring this one down here. So we shall have cx, then natural log of e. Of course, natural log of e is 1, because natural log of e is log base e. And then the e that we are having here is the power. You see that? So if the power and the base are the same, then that logarithm is going to give us a 1. Now, we are making natural log of y the subject. So natural log of y is going to be equal to this cx here, then plus, minus, because this one crosses, okay? When it crosses, it becomes a negative. So minus natural log of k. And then after that, now this one is a linear equation because it is in the format y is equal to mx, then plus c, where the m here, the c here, in this case, is the gradient, and then this is the y-intercept. You see that? Now, using these 2 points that we are given, we can now find a gradient. So gradient is going to be equal to the change in the vertical axis. So we can have 2.21 minus the 0.372. Then we divide by the change in x, which is 5.10 minus 2.80. Then this one we equate to c, that is the gradient here. Okay, so what will be our c? They said give each value correct to 2 significant figures. So let's put this in the calculator. We have 2.21 minus 0.372. Then we divide by 5.10 minus 2.80. So this one is giving us that fraction. Let me first even keep that fraction 919 out of 1150. So to 3 significant figures, to 2 significant figures, what is C? That is, this one is 0.799. So when I round off the third 9, you put it on the second one. So let me write something here. We have 0.7991304 and the rest of those figures, but I'm supposed to write to 2 significant figures. Remember, 0 is not a significant figure unless it is in between other figures. So I'll round off this one to this. I will add a 1. So this becomes 80 or 80. So that means C is going to be 0.80, like that. Then, since we don't know where this line cuts this axis here, we don't know this point here, because that would have been the y-intercept. We just equate it to this one and then we find k. So what we are going to do is to get one of the coordinates here and we substitute, okay? One of the coordinates here and we substitute into the graph, the equation. So we have, if I can use, let's say, this one here, okay? This one is going to be natural log of y. Now I'm substituting here, okay? Natural log of y is 2.21. Don't say natural log of 2.21. Remember, I told you that you check what they have. You check what they have put here, what they have labeled this axis with. It is natural log of y, okay? So that means what you're having here is a natural log. That is where I started from. So I will have now this natural log, 2.21, which is equivalent to the C we have gotten is 919. I'm going to use that exact value, not this 0.80, okay? 1150. And then the X here is this 5.10, 5.10. And then after that, we have minus natural log of K. So in other words, bring this one this side. So we shall have natural log of K, which is equal to this 919 times 5.10 out of 1150 When this one crosses, it's a minus. So we can have minus 2.21. So meaning for us to get k here, to undo natural logarithms, we use exponentials. So it will be e to the power of 919 times 5.10 out of 1150. Okay, then we subtract 2.21. So what will be our k to two significant figures? So we put the whole of this in the calculator. Shift, then natural log, which brings that e, and then we can have 919 times 5.10, then divide by, pardon me here, this is 919. Okay, then down here we shall have 1150, and then minus 2.21. So to two significant figures, I'll just round that 5 to that 4. Okay, I'll just round that 5 to that 4, and then I get 6.5. 6.5 to two significant figures. So that will be that. Next, we are given to express this in partial fractions. So before you express the fraction given into partial fractions, you need to first recognize the degree of the numerator. If the degree of the numerator is greater or equal to the degree of the denominator, always first long divide to make the fraction proper. Okay, so this one here is 6x squared minus 2x plus 2. We divide it by x minus 1 into 2x plus 1. Now, when we try to expand this, x times this, that will be 2x squared. So you have 2x squared here. Then x times 1, you'll get x, then minus the 2x here, you'll get minus x. So we have minus x here. Then negative 1 times 1, that one gives us a negative 1. Then this one is 6x squared minus 2x plus 2. So the degree of the numerator is 2 and the degree of the denominator is 2. The degree is the highest power in the expression, okay? So we need to first long divide to make it a proper fraction. So we are going to have 6x here, the dividend, then minus the 2x plus 2. Then here we have 2x squared minus x minus 1. So 6x squared divided by 2x squared. You just divide the first with the first, okay? The rest you multiply. Here we shall get a 3. Then all of this times the 3. So what do we get? We get 6x squared minus 3x minus 3. Then when we subtract, automatically this one will disappear, okay? Then negative 2x minus 3x. This one is going to be a plus. So meaning we shall remain with x, because you have 3 minus 2, okay? So here we shall remain with x, and then 2 minus 3, this one becomes a plus, and that one gives us a 5. So plus 5 here. So this therefore implies that our 6x squared minus 2x then plus 2 out of the x minus 1 into 2x plus 1 is actually 3, then plus the remainder here, divide by this x minus 1, and then 2x plus 1. Just like you can have something like 7 over 2 is the same as 3, then plus the remainder is 1, then over 2. You see, it is 3.5. So it is 3 plus the 0.5, just like that. Okay, then from there we can reduce what we have gotten here to partial fractions. So I will have x plus 5 divide by x minus 1 into 2x plus 1. Then this one will be equal to a, because we are having linear factors, so a over x minus 1, then plus b out of 2x plus 1. And then without wasting time, just multiply this with this, then this with that, then after you equate to this one here, okay? So we shall have a into 2x plus 1, then plus b into x minus 1, then I equate this one to x plus 5. Now you look out for x values that can terminate one of the terms here, then to remain with the other, that gives you one of the constants. For example, if I let my x to be equal to 1, that means this whole thing is going to go. So here I will have 2, then plus 1, that will be 3 of a. So that will be 3 of a, which is going to be equal to, add a 1 here, it will be a 6. So meaning when you divide all through by 3, our a is going to be equal to 2. Okay, then if x is equivalent to negative a half, in other words, just get this and equate it to 0. Okay, so negative a half, this one will disappear, then we remain with this one now. So we shall have negative a half minus 1, that is negative 3 over 2, or negative 1.5. So that is negative 3 over 2 of b, which is equal to 5 minus a half, that one will be 4.5. 4.5 is the same as 9 over 2. So you can see that these 2 can cancel with that, and then 3 can divide all through, and then your b becomes negative 3. So this therefore implies that 6x squared minus 2x plus 2 out of x minus 1 into 2x plus 1 is equal to 3, then plus our a is 2 over x minus 1, our b is a negative 3, then over 2x plus 1. So this will be the full expression into partial fractions. Question 6, part A. On an Argand diagram, shade the region whose points represent the complex numbers z, which satisfy both the inequalities, this one here and this one. So I've already said that if you see the modular signs, okay, on one side, if you have been following, okay, if you haven't, if this is your first time to see my work here, you can always go through those videos that I've been posting. I've been explaining a lot when it comes to the locus of points. Now, here, a locus is a region which contains the points describing a certain rule, okay? So the points can be on a straight line, the points can be on a curve, the curve can be a circle, the curve can be an arc, you see? The line can be a half line, the line can be a perpendicular bisector, the line can be an angle bisector, things of the sort. Now, if you see the modular signs on one side of the equation, then this implies that you are having a circle. Okay, let me split this one here like this, such that I can do my working this way. Now, this one here, z, pardon me here. So we have z minus, I said always create a negative such that you see, because we have z minus, let's say u, this one is equal to whatever is here. So this one is a circle of center u, then radius r, okay? So we have to create a negative, but then we don't change the meaning, okay? So it is like this, then is equal to, less than or equal to 2. So here we are having a circle. When you open here, okay, it is the same as this. So we are going to have, this one is a circle of radius 2, and then the center is 4, 3. You see that? Now, if we have less than or equal, it means we are looking at inside the circle. When it is equal, then we are on the circumference of the circle, because whichever point that is on the circumference of the circle, it is the same distance from this fixed point to the center. You see that? Then any point inside the circle, its distance from the center here is less than the radius. So less than or equal, it means we have the circumference of the circle and also inside. So when we draw this circle, the circumference has to be bold. But if it were less than, then we would draw the circumference dotted. Okay? So that is that there. Now, let's go to the next one. We are given a half line here. If you see argument, and then they put something in here, you just know that that is an argument. So we are supposed to know where that I mean, that is a half line. We are supposed to know where that half line is starting from. So I also create a negative there. So z minus, then this one is going to be 2, then plus I. So that when I open up, it is minus minus, okay? Then this one is going to give us, this one is greater or equal to pi over 3. So we have a half line here, a half line starting from 2, 1, okay? And then has to make an angle of 60 degrees with the horizontal. Then I'm going to show you if they say greater than, what does it mean? Now I'm going to draw my axis here. Already one is drawn, so let me just add on another one here. Okay, when I add on another one there, that is what we are going to have. Then you can label those axes there. So we can put on, you can actually, to produce a very perfect graph, get your ruler, okay? Get your ruler and then you measure everything. You put, it's a sketch, but to be so accurate, then you can mark those points using the centimeters. So it is going to be very easy for you when you draw the circle. Okay, so I mark those points there. After that, I do the same for the imaginary axis. We are going to look at our center here, which is 4, 3. Okay, 4, 3, maybe it is around there. And then the radius is 2. That means we go 2 units here, you go 2 units down, you go 2 units here, you go 2 units up there, and then you draw your circle like that. Okay, but why I advocate for using the compass and then the ruler, you measure to produce the perfect work, to avoid these kinds of potatoes that you're drawing. All right, so let me get my compass here and then I draw. The radius is 2, but my compass cannot reach up to 2 centimeters. So I'll just put it at 4 and then I'll diminish later. So I put the compass here at the center, which is 4, 3, like that. Okay, and then we draw. So I draw that circle. I'm going to diminish this one here. So my software allows me to do that. I can diminish it until we move 2 units everywhere. So remember, since it is, the radius is 2, then this one has to be a tangent to that circle. You get it? Then also this 6 here has to be a tangent. 2 units up, 2 units on the left, 2 units on the right, 2 units down. So that is the circle. We need to find that point, 2, 1. So 2, 1 is here. Okay, then we can draw a line, the horizontal line, a horizontal line just like that. Then we can even make it dotted. Make it dotted such that it doesn't, actually this circle must be a tangent to it. Okay, the circle has to be a tangent to it, because remember, 3 minus 2, you get a 1. Okay, so something like that. Now we draw, I can get my protractor and then I put it there. I measure 60 degrees. Okay, so you put it here, pi over 3 is 60 degrees. So our 60 is here. Then I can draw from this one here, then I go through that 60 there. That is the half line. But remember, this half line has to be, so this will be pi over 3. So I write my pi over 3. Now, we have to look at points that are inside the circle, but also they are greater than. So when you look at this half line, it is a region between it is a boundary line between two regions. So I have this one here and this way here. So the region that is going to coincide with inside the circle is this other one here. So I'll just shade this one here. It has to be this one here because that is the one which is inside and on the circumference of a circle, and also greater any point that is here, its angle from this horizontal is bigger than the 60 degrees or the pi over 3 there. Okay, so that is going to be our sketch there. Then part B, they are saying calculate the greatest value of the argument of z for points in this region. Now we are supposed to begin from here, argument of z for the points. So how we are supposed to draw the lines connecting, okay, to these points in here from the origin. But of course, the one that is going to give us the greatest argument is going to be the one that is going to act as a tangent to this circle here. Okay, it will produce the biggest what? Angle. So by removing all of this and then we draw something neat, this one is going to be, I just come to this one here and then I draw a tangent there, just like that. Okay, then you know that in circle theorems, a tangent is always perpendicular to the radius. So that means when I connect this one here to the center, this one is going to be 90 degrees here. And this one is 2 units. Okay, the radius of the circle is 2. Now I can also connect this one here to the center and then also connect this one here, just like that. Now I'm going to just dot this one here, make these lines that I've drawn dotted, just like that. So the angle that we need is this one here. Okay, I can call it theta, but I can get this beta here and then can get this alpha here. You see that? Now for us to get this beta here, already from here up to here, we know it is 3. Okay, it is 3 units. So if this is 3 and this is 4 units here, you see that? So I'm going to pull out these triangles and then we solve accordingly. So when I pull out this triangle, sorry, this one here, this one is 3 units, this is 4 units. Okay, so I can find the beta here. So using SOHCAHTOA, this will be tan of beta, which is equal to 3 over 4. So meaning that beta is going to therefore be the arctan of 3 out of 4. But also, when you look at this other one here, for me to get the alpha, there is this side which is opposite to it, but then the hypotenuse, I don't know it. Neither do I know the adjacent. So I can use this triangle here, okay, to get this hypotenuse here. Okay, so by using Pythagoras theorem, this will be the square root of 4 squared plus 3 squared. Okay, so that one is going to give us 5. 16 plus 9, that is 25. Root of 25 is a 5 here. So meaning if I pull out the other triangle, which is like this, it goes like this, then there to the center, and then like that. So this one here is 5 units, and this is alpha. Now this is 2 units. So this is opposite and then hypotenuse. So here we can use sine. That means sine of alpha is going to be equal to the opposite, which is 2 over the hypotenuse, which is 5. Meaning alpha is going to be equal to the arcsine of 2 out of 5. Okay, so that means the greatest argument, okay, the argument of z, I can call it max, that is the greatest argument, is going to be equal to the alpha plus the beta. Okay, so I just come here and I say this is the arcsine of 2 over 5, then plus the beta is the arctan of 3 over 4. So putting all of this together in the calculator, since they never told us whether we should put our answer in degrees or in radians, I can put it in any form that I want, either degrees or radians. Okay, so on the calculator, so my calculator here is in radians, so I will say arcsine of 2 out of 5, then plus the arctan of 3 out of 4. So it gives me 1.06. 1.06. That is to 3 significant figures. This one is in radians. You see? Or if it is in degrees, you just write one answer. Don't write this in the exam. Or then you also write degrees. No. So I'll just come back to this and then I change. Shift, then mod, then degrees, then press equals. It is 60.4 or 60.4 degrees. So just like that. So this has been the first part of this paper. Thank you so much for watching. May God bless you. If you find the videos very helpful to you, kindly like, share, and even subscribe. See you in the next videos.